Welcome. We are going to discuss about binomial series for any power, not necessarily a positive integer as we saw in the previous case. So a statement or theorem. So binomial So this one states that 1 plus x power n will be given by 1 plus nx plus n into n minus 1 over 2 factorial x squared plus n into n minus 1 n minus 2 over 3 factorial x power 3 plus n into n minus 1 n minus 2 n minus 3 divided by 4 factorial x power 4 plus several other terms provided absolute value of x is less than 1. So be the same as saying negative 1 is less than x less than 1. So where n is any number, not necessarily a positive integer. So let's call this a statement of the binomial theorem. Let's call it 1. Let's call this 1. So from this one, I want us to discuss other related formulas to it. So what if I have 1 minus a power negative, say k. So we're going just to say where there's x in 1, you replace by minus a, and where there's n, you replace by minus k. So 1 minus a power minus k is 1 plus where there's n, you put minus k, where there's x, you put minus a, plus minus n is minus k into minus k minus 1. X is the same as minus a squared divided by 2 factorial plus next term, I'll be having minus k into minus k minus 1 minus k minus 2 divided by 3 factorial into minus a power 3 plus other several terms. So let's simplify this. So we'll have 1 minus minus is plus, so I'll have plus ka. Then this one can be written as minus k times, I factor out a minus here, so we have k plus 1. And then minus a squared is just a squared divided by 2 factorial. So you see this negative and this negative cancels out, so just have k into k plus 1 divided by 2 factorial a squared. So this is how the third term will look like. In this case here, I've seen that up to this point, I have k into k plus 1. So this other term, I factor out negative 1, then k plus 2. And you see when you say negative a power 3, since 3 is an odd number, so we have a negative sign. It's like we're multiplying by negative a power 3. So this negative and negative cancels out, so we just have k into k plus 1, k plus 2 over 3 factorial a power 3 plus other several terms. So therefore, we are claiming that if I have 1 minus x power negative n is just 1 plus nx plus n into n plus 1 over 2 factorial x power 2 plus n into n plus 1, n plus 2 over 3 factorial x power 3. Next term will be n into n plus 1, n plus 2, n plus 3 over 4 factorial x power 4 plus other several terms. So here, and remember, the condition still remains that magnitude of x must always be less than 1. So with that in mind, then other several formulas can be generated from that formula 1. So we have 1 minus x raised power negative 1. We just have 1 plus x squared plus x power 3 plus x power 4 plus other several terms. Other formula, if I have 1 plus x raised power negative 1, I'll get 1 minus x plus x squared minus x power 3 plus x power 4 minus x power 5 plus other several terms. C, if I have 1 plus x raised power minus 2, I'll have 1 minus 2x plus 3x squared minus 4x cubed plus other several terms. D, if I have 1 plus x raised power minus 3, I'll have 1 minus 3x plus 6x squared minus other several terms. E, if I have 1 minus x power minus 3 is 1 plus 3x plus 6x squared plus other several terms. Then F, if I have 1 plus x raised power minus n, I have 1 minus n plus n into n plus 1 over 2 factorial x squared, then minus n into n plus 1, n plus 2 over 3 factorial x power 3 plus other several terms. And G, 1 minus x power n is 1 minus nx plus n into n minus 1 over 2 factorial x squared minus n into n minus 1, n minus 2 over 3 factorial x power 3 plus other several terms. So the main formula is this formula that we have stated in 1. And then from this formula, you can always generate more other formulas. Note that when you are using this, you have always to ensure that the coefficient at the starting number in the binomial expression is 1. So this must always be 1. And also ensure that this magnitude of this value is less than 1. So let's do an example involving rational expansions. So the question is, expand 1 over square root of 4 plus x up to the term in x power 3 and state the interval where expansion is valid. Now, to work out this, just rewrite this expression as a binomial. So 1 over root 4 plus x can be written as 1 over 4 plus x power half, which is the same as 4 plus x power negative a half. Now, to use formula 1, we will have to ensure that the starting number in the binomial expression is 1. So this can be written as 4 into 1 plus x over 4 raised power negative a half. Note that when you open the brackets, you still get back your original expression. So loss of indices tells us that this will be given by 4 raised power negative a half into 1 plus x over 4 power negative a half. So then now, the same as 1 over 4 power half, 1 plus x over 4 power negative a half. So 4 raised power half is 2. So a half into 1 plus x over 4 power negative a half. So therefore, n is negative a half. And for this expansion to be valid, then we expect that the magnitude of x over 4 should be less than 1, which is the same thing as saying that magnitude of x should be less than 4. So this is the condition. Condition for which the expansion is valid. Now, let's now have 1 over 2, 1 plus x over 4 power negative a half. So we'll be given by a half, then 1 plus n is minus a half times x over 4 plus 2 factorial minus a half into minus a half minus 1 x over 4 power 2 plus next term will be negative a half into negative a half minus 1 negative a half minus 2 divided by 3 factorial x over 4 cubed. And because we were just to expand up to term in x power 3, so we stop at that point. So we'll have a half into 1 minus x over 8, 2 by 4. And then when you expand this, we'll have a plus minus a half times minus. So minus a half minus 1, like I have minus 3 over 2. So minus over 2 times x squared over 16 plus minus a half times minus 3 over 2 times minus 5 over 2. When I open this, I'll get, so I divide this one by 6, x power 3 4 power 3 is 64, plus other several terms. Now I multiply by half. The first term will give me a half minus 1 over 16 x. If I multiply this by 1 over 16 by a half, I should get 3 over 256 x squared. If we open this, multiply, divide by 6 and multiply by 1 over 64 times a half, you get minus 5 over 2048 x power 3. So that will be the solution. Next question, expand 1 over 1 minus 4 x squared. So for this, we write it as one minus 4x power minus 2. So which means that the expansion is valid when minus 4x is less than 1. So which means x should be less than 1 over 4. So n is negative 2. So 1 minus 4x power negative 2 would be 1 plus n is minus 2 minus 4x plus minus 2 into minus 2 minus 1 over 2 factorial minus 4x squared plus minus 2 minus 2 minus 1 minus 2 minus 2 over 3 factorial minus 4x power 3 plus other several terms. So when you open, we get 1 plus 8x plus 48 x squared plus 256 x power 3 plus other several terms. And then next, expand square root of 1 minus x up to the term in x power 3, stating the value for which the expansion is valid. Now, this is the same as square root of 1 minus x is 1 minus x power half. Then we expect the expansion to be valid when minus x absolute is less than 1. We get the same thing as saying absolute value of x is less than 1. So this condition for validity of expansion. So once you have ensured that this first term is 1, then this other term, its absolute value must be less than 1. So this is a condition. So here n is a half. So 1 minus x power half equals to 1 plus a half into minus x plus a half into a half minus 1 over 2 factorial minus x power 2, a half into a half minus 1, a half minus 2, over 3 factorial minus x power 3 plus other several terms. So 1 minus x power half will be 1 minus a half x. Now, when you simplify this part, we have a half minus 1 is minus a half times a half. It's 1 over 4. Divided by 2 is 1 over 8. Negative 1 over 8 because we had a negative here. We'll have negative 1 over 8 x squared. And when you open this, you will get negative 1 over 16 x power 3. So if the question was, hence, use your expansion to approximate square root of 24. So this note, we had 1 minus x square root. So if you have square root of 24, so really the same as 1 minus minus 23. So this is what will give us 24. But then this one is valid for expansion only for absolute value of x being less than 1, i.e., x will be lying between negative 1 and 1. So which means we cannot substitute x to be minus 23 to solve root 24, as we used to do in the case of positive integer index. So here, we manipulate surds to give root 24 is the same as square root of 25 times 0.96, which is the same as root 25 times square root of 0.96, which is the same as square root of 0.96. And now, square root of 0.96 is the same as square root of 1 minus 0.04. So when we let x to be 0.04, we have square root of 24, which is the same as 5 root 0.96 will be 5 into, we are replacing here by 0.04. So 1 minus a half times 0.04 minus 1 over 8, 0.04 squared minus 1 over 16, 0.04 power 3. So this will give us 5 times 1 minus 0.02, 0002 1, 2, 3, 4, 5. So which is 4.89898 to nearest 5 decimal places. So know that there's some small variation on how we use expansions for rational powers to approximate square roots of numbers raised to some index, unlike the case when we were solving the problems on positive integer power, the binomial expansion. Lastly, expand expand 1 over minus 1 minus 4x power 2 in ascending powers of x up to and including the term in x power 3. Then that's 1. And then 2, find the coefficient of x squared in the expansion of 1 plus 3x squared divided by 1 minus 4x power 2. So let's start by the first case. So part 1. So 1 over 1 minus 4x squared is the same as 1 minus 4x power minus 2. So which implies expansion is valid for absolute value of minus 4x less than 1, which means absolute value of x less than 1 over 4. Or negative 1 over 4 less than x less than 1 over 4. So n is negative 2. So therefore 1 minus 4x power minus 2 would be 1 plus minus 2 times minus 4x plus minus 2 minus 2 minus 1 over 2 factorial minus 4x squared plus minus 2 minus 2 minus 1 minus 2 minus 2 over 3 factorial minus 4x power 3 plus other several terms. So the first term will give us 1 plus 8x. When you expand this, you get plus 48x squared. This one will give us plus 256x power 3. Then next was to find the coefficient of x squared in this expansion. So note in case 2 that 1 plus 3x squared over 1 minus 4x squared is the same as 1 plus 3x squared times 1 over 1 minus 4x squared. So which can be written as 1 plus 3x squared. Now this as a series is 1 plus 8x plus 48x squared plus 256 x power 3. And then this is a bracket to expand. So it will be 1 plus 6x plus 9x squared. So you multiply by 1 plus 8x plus 48x squared plus 256 x power 3. Now we are interested in getting the coefficient of x squared. So we'll have 1 times 48x squared. So that will give us an x squared term. Then 6x should be multiplied by 8x squared. By 8x so that we get an x squared. And then this should be multiplied by 1 to give us an x squared. So this will be the only terms we have which have x squared in this expansion. So we'll have 48 plus 48 x squared. So it means coefficient of x squared is 48 plus 48 plus 9, which is 105. So therefore the coefficient of in the expansion of 1 plus 3x squared over 1 minus 4x squared is 105.